Okay, welcome everyone.
Hi folks, welcome. Sean, good to see you. You can unmute yourself if that's Kristen. I don't know if they can right now.
They should be able to. Yep.
Okay. Hi Adam, how are you?
Good. How you doing?
Good.
Good to see you without a mask for a change.
Well, it's off just because I'm in my prep, so no kids are around.
Nice. Let's see. I think I saw some other folks that I know here. Mosin, I see. Welcome. And if there's anybody else I've met before. Hi, Mosin.
How are you doing?
Good. Welcome. I think this is our first video meeting.
Yes, it is.
Excellent.
And I also have one of our grad students on the call, Omkar, who will be helping with the new lab. We have a collaborative robot, yeah. So this one.
All right. Okay. Okay, well, I think we're gonna get started here, and some people may trickle in. We'll do some brief introductions on the AET side of things, and today we're gonna launch in. I'll take this slide off here. Give me 1 second. So we will we'll do some quick introductions, and then I'm just gonna do a little bit of show and tell with our universal robotics system. At least one of our viewers here has one of these systems in their school, and I'm happy to answer any questions. And I'd also love to hear from you folks on what you are doing with robotics in your academic setting. So quickly, my name is Adam Zelny. I'm the application specialist with AET Labs. I coordinate with the sales team and get out into the field to do everything from pre-sales to setting up a variety of systems that AET Labs works with, and training teachers on everything from beginner applications to advanced. And I guess we can go around if you guys want to share. Kristen.
Hi everyone, I'm Kristen. I work in marketing. If you have any ideas for any other events that you'd like us to hold, please let me know. And I want to let you all know that you'll receive a copy of the recording tomorrow.
Matt
Campbell. I'm the technology consultant in Eastern New England, primarily higher ed, but also have some K through 12 accounts as well.
Justin.
Hey guys, Justin Tursky, technology consultant. I work in Connecticut, Western Mass, and Vermont. And thanks for joining us today. Thanks,
guys. So the first thing, before I kind of just jump into my demo here, I would like to ask, and you're welcome to use the chat, which I just typed in. If you are having trouble finding the chat, feel free to unmute yourself and we can help you with that. I'm just wondering how many of you are currently working with robotics in your classroom, like as in you have a robotic system of any kind. And if you want to unmute and just say we do and share what you have, that's fine too. All right, so Casey has Vex. Yep, very common one. All right, Sean. I know Sean has a UR5, which is actually what I'm going to be showing today. All right, if anyone else wants to chime in, if we missed you, please do.
Adam, I believe we will have, we don't have it yet, but we have a UR5 for Pistol Lab, and also a CR, I don't know what model, but a FANUC CR robot.
Okay, great. Awesome. Okay, so you have a UR5. Is that from us?
It's a part of the Festo Cyber Physical Factory Lab.
Okay, gotcha.
Yeah.
Yep.
Work with AET Labs with Dave, so I'm not sure if it's through you or Festo. Yes.
Okay, excellent. All right. Okay, so what I'm going to start with here is this is going to be a fairly basic overview, and I also want to share that we are planning the next couple of Tech Tuesday events next month and the month after to have guests from either Stratasys, which is our 3D printing partner, or Universal Robots themselves. So I'm looking forward to kind of getting into a little bit more advanced stuff down the line. So right now I am going to do a quick share on my phone. Okay, so right now you are looking at the AET Labs demo room. We have a few machines in here, a couple of Stratasys 3D printers, a Protomax water jet cutter, and these UR systems that I recently assembled for Old Colony High School. And this is the guy we're going to look at right now. So let me just get this in here. All right, and what we're going to do is I'm going to show you the physical program, the actual robot running the program, and then we're going to move over to the teach pendant, which is this guy right here. So the big thing about the Universal Robots is the term collaborative robots, and that this system is really designed to be worked with in a variety of like lab environments, and we're really meant to be working side by side with this robot. And the versatility is really the big feature of this system, is being able to change things on the fly, quickly change them, and have it adapt to different scenarios. So what we're going to do is we'll run a fairly simple program, and I'm running this program slowly. We'll see what it does here. Pretty self-explanatory. We are going to come down and pick up our block, move it up to the conveyor, hit a sensor, which stops the conveyor for a brief moment, funnel the block down, which hits another sensor to trigger the robot to move over and pick it up, and place it down. Now, again, just as like kind of a demo here, I'll run it one more time as I'm talking through it. Just as a demo here, I had been experimenting with a few things that I can't really show you right now because I didn't finish the programming, but a couple of neat features I incorporated in this when I was testing it out was a gripper check. So the gripper would come down, and if it actually closed and did not find anything, it would just go back to its home position. Okay. All right, so that's that. Now what we're going to go do is take a look at what's called Polyscope. So Polyscope is the user interface software. Make sure I can really get you a close look here. All right, so if you are new to Teams and you are having trouble seeing anything that's on the screen right now, you should be able to, Kristen, you might need to help me here, but I think there is an option to do what's called pin.
Yeah, actually, I was looking to see if I could do that.
I think it's either pin or focus, and it will kind of remove your the view screen of the other visitors and kind of enlarge the screen. So
you click on the three dots and then click on focus on content. That'll do.
Thank you, Matt. Yep, that's it. Thank you. Okay. All right, so here is a Polyscope interface, and this is kind of the first thing you see when you power up the robot, is simply just choosing an active payload, which we can program, and then a simple power-up sequence, which just releases the brakes on the stepper motors. From here, we can kind of get acclimated to the robot by clicking on, our move panel. You can actually give yourself different views of the simulation here. And of course, the simulation is mirroring the actual video of, or the actual positioning of the robot. We have TCP position, or TCP is tool center point, so which is also programmable. So in this case, I can move our tool. Let me see if I zoom in here so you can see this better. So I can move my tool center point up and down, left and right, as is a very intuitive direction. If I was standing in front of the robot, it comes toward me, it goes away from me, it goes to the left and to the right. A great way to get like a newcomer to robotics and someone who's kind of not familiar with translational movement or moving in virtual space, because as soon as you start getting into advanced robotics, it gets a little confusing. For example, right now we're moving based on the TCP, but we could be moving based on like an XYZ axis that's homed down here at the base. Another huge thing about or a feature of this robot is free drive, which you see here. But free drive actually pops up, and I'm going to just flip this around a little bit so you can see it. On the back of our controller here, there is a brake release button, or we'll call it a free drive button. And when we're holding this teach pad, we can easily access this free drive button. And what this free drive button does is it releases our stepper brakes, and we can drive the robot, and I'll show you this later. We can drive the robot with our hand. So I can just hold free drive with one hand, and this little free drive interface comes up, and then I can physically grab the robot and move it around. It also has these really great simple constraint features. So if I want to only free drive based on like a straight line in XYZ, or only on XY, I can do that. If I wanted to constrain just Z, very, very quickly, just do a couple of, hey, Dave, do you want to come in for a minute? So I'm going to have AET's founder, Dave Kempsky, come on in and help me out. I was wondering if you wouldn't mind, I'm just going to show them quickly the free drive. Yeah. So do you mind grabbing this and going on over? Okay, so if you don't mind, go ahead and hit free drive. Yeah. Back. Yeah. And right now we just have Z constrained. So if Dave tries to move the robot like left and right, it's not happening, but he can move in a perfect linear direction. In this case, just probably down. Nope. Oh, it's on a, oh, I see, okay. Oh, no, that's okay. Go back to free drive and just tap that guy right there. Yep. And now try up and down. No movement. Oh, it's saying singularity. Okay, try this guy. Let's just move it out a little bit. Yeah. There we go. Yeah. And now, so now it's free drive and all axes are available. Okay, so now if I hit this one. Yeah. Yep. There we go. Oh, that's cool. Yep. Oh, wow. Yeah. I didn't know I could do that. Yes. That's exciting. So what we were hitting before was a singularity. So it was basically saying that the joints can't move that way. And you can actually see the screen change in color to represent those limitations. Oh, so you can go this way too. Yep. So it's not pushing down like it's happening that way. Yeah. That is, I learned so many new features all the time. So on a very basic level, this feature for programming the robot. And that's what I did when we did our little pick and place with the block here. I would move the robot down here and set a waypoint. And then I would move the robot up here and set a waypoint, all using FreeDrive. Very, very, very quick and intuitive way to program the robot. Thanks, Dave.
Anytime, Alex.
Appreciate it. All right, so let's now go back and take a closer look at this program. And see if we can just, I can quickly show you what's happening here. All right, so our program tree on the left, and you know what, I can probably give you an even closer view of this. 1 second. All right. So we have this like really wonderful collapsible program tree here that governs creating our programs. And in our program here, we have, you know, this is just my own personal terms for like APP as approach. So we have a waypoint for home, approach block 2, pick 1, gripper close, and then a series of commands that bring it over to the conveyor and all the subsequent stuff, like, you know, if the sensor is detecting an object, wait for a moment and bring this back up. And this is really the heart of our user interface. You have like a really nicely laid out menu over here to add programs. And we have all the kind of variables on the right side here. And I should invite you all to, if you have any questions while I'm kind of scanning through stuff or talking about stuff, by all means, jump on in, unmute yourself, ask a question, type something in the chat. All right, so the next thing I want to show you, the program that we ran was very, very slow. And I did that on purpose just so we could see it. But in here, if we wanted to bump up our speed, I can add, so a move J in this case, and if you're kind of new to the terminology, a move J is like a joint movement. So it really, it's the most liberal way for the robot to move from point A to point B. But I can have, you know, a list here of waypoints and actions under this move. And if I change my joint speed, let's do 80. Then all of my waypoints and my movements are updated. And same thing for this one, we'll do 80. And this one, 80. And this one, I think, is just going home. We'll just leave that. All right, so quick update, and we are going to move much faster. The other thing that I really love about this system is the use of features. And features we can find in the installation tab right here. And a feature is essentially, you know, if you're familiar with CAD design, points, lines, planes are all incorporated in that sort of level of design. So we can create a point feature, a line feature, a plane feature. In this case, if I wanted to create a plane, I can go straight to a wizard, in this case, teach this plane. And using the FreeDrive button, I can move the robot around. Actually, I might as well just show you. So I can now, with the wizard, set it 3 positions that essentially triangulate a plane. And in this case, my goal here, and Kristen, by all means, actually I can sort of see over here. My goal here is going to be to use my tool center point to create a plane that would be perpendicular to the conveyor in front. So I'm going to click OK, go to my next position, use the free drive to move it over here. Click OK. And my final position, I'll bring down here. And click OK. And now you can see that a plane was created. It's a little lopsided, but I can now use this plane to dictate a safety, essentially a safety plane where we cannot program the robot or move the robot beyond this plane. It's very, very easy to do that. So let's say you have a tight lab space and you want to make sure that this robot in no way, shape, or form could actually move to obstruct something or knock something over. You can set up safety planes very, very easily. Okay. All right. So the other reason I would use planes is if I were changing the height of an actual work plane. So if I suddenly wanted to move to, let's say I wanted to move the robot to a different location that is no longer interfacing with a table at this height, but a table at this height, I can do a very, very simple update to my program. And let's go back to our program. And what we're going to now do is go to my move J here. So my second set of move commands have approach table, place table, gripper open, and approach table to like move back to that approach position. And if you see over here, we have the feature set to table. But I set another plane called table plus box. So if I switch that, that's all I have to do. And go back to start my program. Let me see if I can bring up my camera a little bit. So our speed has been updated. And our final set of move commands to reflect the height of the box, which is just, it's so cool how easily done that is. You can program a plane, you can update a plane. And in this case, for updating, let's take a look here. Table plus box. Let's just delete that last one we did. Oh, I'm sorry. So I can go into my feature, my edit view here and say table plus box. And this just kind of flipped it upside down because this is this feature is based off of the tool center point, I think. But I can go in here and just simply change my Z value by less or more in order to update, like, you know, the height of the table, which is pretty cool. And of course, that, you know, you're not limited to just a flat table. You can, or I should say, you're not limited to a table that's like parallel to your floor. You can change your work plane to be, you know, like this if you wanted to, or at any given angle. All right, any questions at this point in time? Okay. All right, let's see. All right, so I'm going to take a little break from demoing, and I want to share. A video and just kind of show you some resources and pop over to Universal Robots website. But the video I would like to show you is one I made using a template feature in Polyscope in the Universal Robots controller. So the template's available here. I know I'm not showing, I don't have it up right now. Hold on one second. So under our program menu here, we have templates. And some of these templates are seek, force, palletizing, conveyor tracking, screw driving. And these are oh, I see this is sideways. Sorry about that. Let me switch that. These templates are just pre-made scripts that allow for an easier access to something like palletizing. All right, where you essentially go through a palletizing wizard step by step and enter values and use your cobot by doing free drive to move to certain points. So let's say we wanted to move over here. So we wanted to palletize a grid of, let's say, I don't know, 30 by 20 small components that were on a pallet right here. I would then use free drive, and I can position over my four corners and have it do a pick and place program just based off of those four corners and the dimensions, of course, of the object that we're picking. So that is one of the neat features of like a palletizing wizard. Force is another one. Let's say if you were working with like an end effector or something at the end of the arm of the robot that was like a suction cup or a suction gripper or perhaps an orbital machine, like a lot of robots are used in the automotive industry, for example, for you know, sanding contour components with contours. You can use your force template to say, okay, we're going to follow this path, but we're going to apply a certain amount of force throughout the path. So it's pretty neat that these wizards are available. So share here. And on the subject of wizards with Polyscope, it's just chock full of them. You know, there are a bunch of wizards that kind of help guide you along that essentially are training you for the more advanced features of the system. Great way to integrate robotics to someone who has never done it before. Okay, let's see here. I am going to just take just a few seconds to find this file. If any of like Dave, Matt, Justin, if any of you guys would like to pop in or have any comments or anything you've seen out in the field, please jump on in.
Adam, great job. If anything, I wanted to say, in my research and the work that I've done with Universal Robot, I find that there's just the collaborative robots are opening up so many different applications, and they're not the traditional applications that we think of. And that is just the point I want to make, because working next to a robot that's not in a cage opens up possibilities for so many things. I mean, just look at the design of the robot that we have, just on wheels, rolled up next to a table, and we're able to interact with it the way we are. So I just think that it just blows open the doors for so many different applications, and it's going to be amazing. You get these in the hands of students who aren't used to working with an industrial robot, what they're going to come up with for use. So a lot of fun things too. So
thanks, Dave. And you know, that kind of just segues right into just sharing Universal Robot's site as a resource. A lot of the companies we work with have gone to great lengths to make sure that their online resources are robust. And on the UR site, we have an applications icon right here that lets you jump right into topics like assembly, dispensing, finishing. This is the one I've told Dave this multiple times, but this is the one I wish I could really get into. We haven't paired up any end effectors with a buffer or sander, but I would love to learn more about this process and the idea that you could upload a CAD model into Polyscope and have this robot do like some finishing work after you do the sanding work. It's just great. And if you haven't seen videos on it, I would encourage you to jump in. Dave, you might know this better than I, but what companies are currently using Universal Robots in their factories? Like, again, I keep going to auto because I've seen robot arms doing this sort of work in automotive manufacturing. Oh, welding. Welding is an interesting one. I've seen some of these setups as well.
yeah, welding is one. Machine tending is really a great application, because with machine tending, using an industrial robot, you really limit the space in which the human can interface with the CNC machine. There's always going to be some interaction next to that CNC machine, so it really makes it nice to be able to be right next to that robot. If you do get bumped by it, you're not going to have to worry about getting injured, or you're not going to be closed by a cage. So,
right. And that's another feature we could show off before we finish is the, it's just by default, if you're using the UR system and it does move in an, or behave in a fashion that you didn't expect, or maybe you programmed it in a way where it hit something and it was a user error, it has safety defaults that it will just stop the robot and lock up all of the motors before it can cause any damage. Okay, so just before that, I did want to show you a video up here. And I was talking about the palletizing feature, so I was kind of getting my hands into that, and I had a lot of fun programming this. And what we're looking at here is not simply the palletizing feature, where I use the four corners of a 3x3 grid to get it to place all of these in the location, but we're also looking at the wrist camera in action. So the systems that I just used in real time today also have wrist cameras on them by the company Robotique, as you can see on this one here. So in this video, you can see me on the left placing down these little hose, I don't know what the formal term is, but hose fixtures. Start it over. And I'm placing them, just like I'm placing them down kind of randomly. And our wrist camera comes up and takes a look at the surface and picks them up. So this was paired with the palletizing template. And this, we talk about programming the robots in 20 minutes. And of course, I'm sure all of you would understand that that could be it could really be anything from 5 minutes to hours or days. And but 20 minutes is like you could get to something like this. You could program like a palletizing program in about 20 minutes. So really very, very fast and streamlined process. The other thing I want to share, and this is something that I'm out in the field a lot and visiting schools, but whenever I have time to work with these robots is a pleasure, because I get to take like the next step in what I'm interested in when I think about you teachers. And I really want to share this with you guys because I know some of you have laser cutters out there. So, and Dave, if you don't mind, I might pop into your office just to take a look at the laser. Is that all right?
Go right ahead.
Okay, thank you. All right, so hold on, I'm going to share one more time. While I'm doing this, I should also point out that Polyscope here is, you can do simulation versions. So I have run VMware or a virtual machine on my Windows desktop to access like just a simulated version of Polyscope. So if you are interested in incorporating this into the classroom environment where you have a bunch of students that need to kind of have just a general overview of the software, it is totally possible to set that up. And I can't show you exactly, I don't have this program, but I did want, hey Dave, thank you. We have this Epilogue Fusion Edge in here, really, really nice laser cutter. And I had this, I really had this great idea, and I hope sometime a teacher will do this, and some teachers out there probably are doing it. But if you have a suction gripper on your universal robot arm, how perfect would it be to come in here and tend this machine, right? So you finish your laser cut job. Let me pull some of this stuff out for a second. All right, so we have like a piece of MDF here. So let's say you have a student working on a project that is an assembly, or maybe it is something that's going to have, you bought 50 sheets of MDF and you're going to be cutting every single sheet, but you have your UR programmed to come in, use its suction gripper to come down and pick up every part, stack it off to the side as you go and do something else more productive than taking it out. So this is personally what I want to work on next whenever we actually get a gripper. So not much fancy to see here, but if you're visualizing it, the robot arm coming in, picking up each part. But what a great application for like a multi-purpose lab, a digital fabrication space, a maker space. And now, actually, this topic is probably a good point to invite you folks to share how you've been incorporating robotics and what you might be interested in down the road. If you have questions about UR specifically and want to know, can I do this with a universal robot system? I'd love to hear from you. So Casey, for example, you said you're using VEX. Are you interested in sharing what you've been up to with the VEX systems or what the students have been up to?
Sure, but it'll be coming up this spring. I have not used the VEX during COVID because we were out both spring, the end of the spring. And then last year we were, some kids in, some kids out. So we just didn't bring out the VEX. But thinking of the VEX, it's a lot of parts, it's cumbersome. And that's why I was and I don't even know. I mean, we've had them in our district at least over 10 years. So I just don't know if, what's the latest and greatest thing is kind of what I was thinking for. And that when you had this, when you demonstrated this, it sparked my interest.
Sure. So what's your overall opinion of just from seeing this today? Of course, VEX, and this is very different, right? This is very much program driven. VEX, you're building the robot up from scratch.
Right, which, it's nice, but it takes a lot of time. And, we don't have a lot of time where I think, today it's the programming and the ease, and you got to wow the kids right away or you lose them. So that's why I think this would be something that they would be very interested in.
Great, thank you. Sean, have you guys had a chance to turn on your UR5? I know I've checked in with you about this like months ago. At this
Hasn't been plugged in yet. I was just trying to figure out dates to get you down here. So
I'm waiting on it. Yeah, I'm waiting on it. Yeah, it's very exciting to do those trainings because it's like all hands on. So
yeah, and I'm just looking what I can do with it. I mean, I got that sim class with Project Lead the Way, so I can do palletizing in that. Maybe someday look at a sander because kids hate the sand, so maybe that could do the job for us.
Sure. Yeah,
I hate the sand.
Right. What's interesting about these UR systems going into the schools, as far as like our customers are concerned, we have all of our systems just have grippers and a wrist camera, and we haven't had any calls yet for to do like a suction gripper or something a little bit more advanced. And I'm really interested to hear from schools that are incorporating those. I think that the gripper is just so common for high schools, because it's like perfect entry level application to use a gripper. But I'm still like doing more advanced stuff with just the gripper, like just like doing a gripper check to see if the gripper is grabbing something, or dimensional accuracy. You can actually have it come in and apply a certain amount of force and grab something that's very delicate versus something that needs to grip a little bit stronger. So it's pretty neat. Anybody else interested in sharing?
Is there anyone else using it in their classrooms that's online with us?
Yeah, anybody else have other? I know Mosin said that they have a UR, but I don't know if they've integrated it yet.
No, we have not. We are in the process of setting up a new lab with AET Labs and Festo Didactic, and we'll have a UR5, I believe, and in that case, the robot is, the task is assembling a product that resembles a cell phone. So it's mostly pick and place and assembly operations. And we also have another, like a FANUC CR robot, I believe, it's a 7-axis robot for machine tending. It has, the entire lab will be commissioned in mid-March. So we are almost 40 days, less than 40 days.
And I wish I had remembered earlier, but do you folks mind sharing where you're at? Like what school you're at?
Northeastern University.
Yeah, and specifically what lab, Mosin?
Oh, I'm an assistant professor in mechanical and industrial engineering department, and this lab is mostly for undergraduate and graduate education. I teach a core course in manufacturing to our undergraduate students in industrial engineering, and we're also in the process of starting a new master's, advanced and intelligent manufacturing master's program. So the lab will serve that purpose as well.
So we hope to do one of our next Tech Tuesdays in your lab, Mosin.
Absolutely. And
I'm excited to get it set up.
Yeah, we had this conversation with Mike Nager when they visited last month, that we should we should start thinking about some summer camps or workshops, etc. And the department is also very interested in these kinds of
absolutely
activities. Adam, I have a some like general question about programming the UR5 robots. You know, before sort of like setting up this lab, I used to teach, and I still teach CAD-based robot programming using Octopus. Like there are other like solutions like Robot Master. So my question is, have you ever done any CAD-based robot programming on these UR robots, or?
I have not, but so I'm a novice roboticist. I'm a novice programmer, and UR has been really perfect for someone with my digital fabrication background and my like small programming background. But I can speak to that directly because I stumbled upon a podcast recently that Universal Robots is doing, and they were just talking, and Dave, you might be able to chime in here, but they were just talking about bin picking and how they are using I assume it's like a template, but it's essentially a template that gets integrated with 3D scanning in order to do bin picking. What is it called? It's Dave, you know what?
Actinav.
Actinav, yes.
Yeah,
Actinav.
it's another product that they sell as an add-on to the robot.
Yeah.
Pretty cool.
Yeah,
So
it's
let me
interesting because like in those like programming, CAD-based programming, you can also do like more complex programs. You have the CAD file, you generate the program based on that. And I came across a link. I'll share that in the chat.
Yep, and I just put a link to Actinav in the chat too. But I was just listening to these guys talk about it and the ease of use being a huge aspect of Actinav. It's worth taking a look into.
Absolutely.
The other thing too is the UR Plus partners site, and that is one of the things that these third-party products. So Actinav is one of their own products, but it was a third-party product that they now brought in as one of their solutions, one of their branded solutions, because it's so popular. But there are some really you might not even see them on the website, because they may not get the recognition from UR because they're maybe a little bit too obscure for the general industrial world. But kind of the things that you're looking for, Mohsen, they're out there. I've run across them, and Adam, the more you spend in this world, I think you'll find them too.
Sure.
But that's the great thing about UR is they've opened up their platform for these third-party companies, third-party platforms, third-party applications for anything. You could be a high school kid that just wants to create an app, control user app, and they've opened it up like that. Great project, by the way, I think.
Yeah, and on the topic of kind of creating custom apps, Justin and I visited University of Connecticut, Hartford, University of Hartford, Justin?
University of Hartford.
Yeah, and one of the robotics professors there got a UR3 from us, and which is the smaller, this guy right here, the smaller of the two. And his goal was to essentially hack it and just start writing his own script right away. So ease of use, he wasn't interested in ease of use. He was interested in is the most challenging application possible, which was really great.
You have to be that. You don't have to really hack it, because you can, it's a developer's kit that PC developer's kit you can get. But maybe he wanted to go beyond, I think, the parameters. So he was probably voiding the warranty, I think, on it.
Maybe, yeah. But yeah, thanks, Dave. Yeah, not hacking, but doing some custom code, which is what the UR Plus developers are doing. When you hook up a wrist camera, it's the developers at Robotique writing custom scripts that gets smoothly integrated for plug and play. I mean, really, to set up these wrist cams, you put it on the end of the arm and you plug in a couple of USBs and you're pretty much ready to go. Casey, can I ask, if you're still on with us, can I ask where you are teaching?
Sure, I'm also eating a little lunch, so.
No worries, thank you.
Yeah, so I'm at Bunnell High School in Stratford, Connecticut. And I've been with you guys for a couple of years now, coming up for different seminars and stuff. I just like your approach. So that's where I came up to, probably a couple of years ago, up to where you are in Massachusetts. Are you still in the same building?
Well, we're in Essex. The main office where Dave and I are right now is in Essex, and it might be, do you remember what the event was?
Is that outside of, where's Holy Cross? Outside of,
That's Worcester.
Worcester. So I was up in
no.
Worcester.
Oh, you're in Worcester for an AET event. Dave, do you know what that is? Which one that was?
It could have been at Worcester Tech. It could have been, you know.
Yeah, it was definitely for laser cutters.
Yeah.
Cool.
Maybe 3 years ago.
Yeah.
Excellent.
Because we have an
It's
epilogue.
a lifetime ago.
Yeah, we have an epilogue, a big one, and I'm just not comfortable using it. So I don't know. My partners at Stratford High have a smaller one, and I always want to kind of switch with them. It's just, I don't know, I don't have a comfort level for it, unfortunately.
Well, yeah, I don't know if this is if it's shared in the kind of the aftermath of the meeting, but I'll type in my email here. And Casey, if you do ever want to reach out with respect to, you know, just having a quick call on that, and you know, we could possibly just do something like a half-day professional development, or we could, you know, meet on the system. Bring you up to
Originally
speed.
we were using it to go from Revit to AutoCAD to print out blueprints to make model houses. And it was that conversion, getting from the Revit to the AutoCAD was okay, but getting from the AutoCAD to get it to print I was just not successful. And then they said to get Corel Draw, which I did, but then we were out, so I never used it. So, you know, it's a piece of equipment that we have that I would like to learn more on. But I'm just, to play around with it myself, I'm not that comfortable.
Gotcha. All right. Well, yeah, please reach out when you feel ready for it. Okay. Sean, do you want to share where you're from?
Sure. I'm from Shepherd Hill Regional High School. I do have one of the UR5s. I just looked at them that Autodesk partners with UR5. So Autodesk, they write AutoCAD and all those other CAD software. So I'm sure they're going to be down the pipeline that you can code from there. And going back to Casey on the laser, going from AutoCAD to Corel or Illustrator, you need a DXF file, which is really a pain lately. I've had struggles with that, but I love that. I love that laser, even though it's down right now. We use it for everything. It's so
versatile. Yeah, I also need to get an exhaust system, because now I take the dryer hose and I have to climb up and hang it out a window.
Oh yeah.
So it's a process.
Yeah.
Sure. Yeah, and again, feel free to reach out to us. We package really, really nice and compact modular systems with those lasers. So if you don't want to bother with that anymore, or you ever need to relocate the machine, or you eventually invest in a smaller machine, they're nice to have.
Thank you.
Okay, I think we're kind of wrapping it up here. I did share a link to ActiNav. That's, I would say that's more at the university level, but I'll also just you guys can just do a search for Universal Robots, but pop on the Universal Robots website. I would say that hands down, if you're either personally interested in getting robotics in your class, or you have kind of an order to incorporate robotics into your class, and you're like, gee, where do I go next? How am I incorporating this? Get some inspiration straight from UR's site. But that's one of the things I was thinking about when I was prepping for this meeting. I went straight to the laser cutter. I'm like, oh, wouldn't it be perfect to just have a nice pick and place application to take all your parts out of the laser, remove the stock and put it in the trash after it's done. So, but that's just the start, right? That's a nice entry level program. Where you go from there is, could be situational. Like what do you need to solve? What do you need to automate in your classroom? Is the best question to ask yourself. What could you automate? All right, I'll just ask from my team. Do you guys have anything to share before we wrap up?
Great job, Adam.
Good. Thank you for everyone for joining us. Appreciate it. And if you need additional inspiration, if the UR website doesn't do it for you, feel free to reach out to one of us.
Yes, of course. All right, guys, thank you so much. Kristen, thanks for the co-hosting, always appreciated. And we'll see you next time. Look out for a link in the coming weeks to our next Tech Tuesday.
Thank you very much.
Thank you. Thanks, Adam. Thanks, everyone.
All right,
Bye now.
take care.